Hello everyone. So this paper is about synthesizing images with deep neural networks, and I should emphasize that most of the credit should go to Chuan Li, but he unfortunately couldn't make it to the conference. So synthesizing images is at its core about imposing the right statistical correlations to a bunch of pixels, and we know that deep conv nets are really good at that. So we've seen the inceptionism work by people at Google, which creates rich, if you do variational deconvolution, creates a rich representation of visual classes. And the problem here is that things look still a bit hallucinogenic. So this was improved, for example, by the now meanwhile famous work by Gaddis et al. That we also heard about today, where like imposing some Gaussian statistics on the feature activations gives much more realistic images. Nonetheless, it's still difficult to control the synthesis results and to approach photorealistic results. So, question is, how can we improve on this? And here's our idea. It's super simple. What we do is we just run non-parametric patch-based texture synthesis on the higher levels in the neural network. So we create the feature representation using texture synthesis such that the patches are all consistent with example data. That's the whole thing. It's super simple. Question is, why would we do it and how well does it work? So why would we do it? If you look at the convnet, every feature is a function of a local neighborhood of pixels. And that implies that every pixel is controlled by a local patch of features. So our conjecture is, if all the patches are similar or very close to actual data, then the pixels will be realistic. So we want to get more realistic pixels. This is a prior that we can use, independent how weird the representation network might be. Okay, implementation is very simple. We just copy patches from actual data, and then we iterate this process, always making sure that the overlap region is consistent. We're actually using the texture optimization algorithm by Quadra 2005, which does this a little bit more sophisticated way. So in the bigger pipeline works like this. We have a template image on the right, like this chart drawing, and then we look for patches that are that fit this, but come from a style image. And when assembling the patches, we make sure that the overlap region is consistent. And then we're not doing this on a pixel level, but on the medium level of a VGG19 network. And we're using two scales to get better results. This is also very similar to the paper by Gaddis et al. That you've already seen. And then, similar to their work, we also put a prior on the top level to get an abstract constraint on the overall layout. And then we run, in a ping-pong way, texture optimization and backpropagation in order to optimize the image. So, and after 2 minutes, this is what we get. This is a result. What we see is that we can take this short drawing and we can turn it to something that looks like a photograph. And that is has been very difficult for previous work. And we also see a drawback. The method tends to copy larger blocks of example data, so it's a bit more rigid. So for example, the mouse looks very much like the example mouse. It doesn't adapt as much as the point-wise prior would allow us to do. But then we get the more photorealistic results. Here's another example where we try the style transfer. You just swap input and the other input, and you can see it also does a decent job there. And then finally, we of course tried it out with colleagues in our lab, and they're extremely happy about the results. And I have lots of more examples, and I'm happy to show them to you at the poster. Thanks.